Hi class, welcome to Grad Stats. Our video today is on moderated regression. So we're going to do a quick recap of hierarchical regression that leads us into what is a moderated regression and how do we conduct it, what are the different preparation and conducting steps we need to do, and what information do we need to pull out of the output for reporting a moderated regression and our labs for SPSS in our studio. So first, a quick little review of our hierarchical regression. So we were interested in the increased variance explained by one's perception of person-job fit over and above the contributions already accounted for by the demographic and job design attributes or variables. So each of these looked at the unique contribution of each predictor, holding the other predictors constant. So that's statistically controlling for the other variables in the model. But what we get into with moderated regression is what if the value of a predictor, like let's say autonomy, what if this value actually impacted the relationship between person-job fit and job sat? So in that case, person-job fit would be our focal variable and autonomy might be a moderator. It would moderate or change the relationship between person-job fit and job sat. And that's what we're talking about with moderated regression. We're claiming that the effect of a target or focal predictor on the outcome depends on the values or level of another moderating predictor. And what we get into there is called interaction effects. We have the main effects of the predictors, like the focal predictor has a main effect, the moderating predictor has a main effect, but then the interaction of those two has an interaction effect. And these are typically smaller and harder to detect, which means at the front of a design, of a research design, you already have to account for a larger sample size to detect a smaller effect. And keep that in mind as you're designing a study. As we go into evaluating a moderation, we're going to learn some new skills. We're going to do some transformations to mean center our predictors. And then we're going to still run a partial F test to evaluate the added variation explained by the interaction term itself. And then for significant interactions, we're going to probe the interaction to determine for what values is the focal predictor's relationship with the outcome impacted by that moderating predictor. So what this kind of looks like conceptually in a diagram is that we're looking at the relationship between X and Y that is dependent on values of the moderator. So you could say if you had an outcome of, say, salary, what one's salary was, and maybe that is predicted by someone's self-esteem rating, right? So self-esteem predicts what salary someone comes in at, say, their first job. But maybe that in itself, that relationship, maybe it's moderated by someone's locus of control, that if they have a highly internal locus of control, maybe that impacts the relationship between self-esteem and job salary. So that's just an idea, right? We statistically evaluate for the presence of an interaction between predictors by conducting a moderation analysis. And statistically, a moderation is an interaction or a multiplication of our predictors. So our main effect of our focal predictor, our main effect of our moderating predictor, and then the interaction effect of those two multiplied to each other would be our interaction effect. So let's talk about just our regression equation here for a second. Let's take this one, age and seniority, predicting job satisfaction. That's what our lab's on. So this B sub 1 is the regression coefficient telling us about the relationship between age and job sat. That for every 1 unit increase in age, that job sat would have this change. And that value for the regression coefficient there for B sub 1, it assumes that the relationship between job satisfaction and an employee's age is similar for all employees, no matter how long they've been with the company. So it just holds seniority constant. The relationship between age and job sat is the same for people who've only been there 1 year or people that have been in the company 10 years. Similarly, B sub 2, our regression coefficient for seniority, it's assuming that the relationship between job sat and seniority is similar for all ages. So this relationship here, this for 1 unit increase in seniority, this is the change in job sat. It's predicting right now that that's going to be the same no matter what ages the employees are. Age is held constant. So B sub 3 indicates that the relationship between employees' age and job satisfaction depends on seniority. So right here, that the relationship between age and job sat is dependent on seniority. That's what this term is grabbing. Or we could put it oppositely. We could turn it around, that the relationship between seniority and job sat is dependent on the employee's age. Because you can swap them. Statistically, we're talking about the same thing. Like the statistics program doesn't care if this one is seniority or this one's seniority. You see what I mean? It's just the main effects of this predictor, the main effects of that predictor, and the interaction effects of them multiplied. So it's our research question that guides how we're going to interpret that B sub 3 and how we're going to run the interaction probing. So have a note. In the notes, I mentioned how it's important to describe your sample up front, including the mean, standard deviations, and correlations between your study variables. There's going to be a correlation between seniority and age because in all likelihood, the longer you're alive, the longer you've been at work, right? So it's very reasonable that those are correlated, but looking at their unique contributions, but then also evaluating if there's an interaction between them makes sense for this question. And when you have multiple continuous predictors and an interaction, a moderated regression, you also include your interaction term in your correlations table. So just a heads up. So one thing we need to do to prepare the variables is to center our continuous predictors. And because we're calling one our focal predictor and the other the moderator, you might want to write down which one's going to be your focal, which one's going to be your moderator. And we're going to look at them both ways because, like I said, statistically, it doesn't care. But how you interpret is saying that like seniority moderated the relationship between age and job sat, or you're saying that age moderated the relationship between seniority and job sat. So you got to keep track of which one's your focal and which one's your moderator. So we're going to, in the lab, we'll create new centered terms for age and seniority, and we do that by taking the raw score minus mean. And we'll do that with creating a new variable. We're also going to create an interaction term, which, like I said, is multiplying those two together. Another new skill or repeat of our hierarchical skills is we want the partial F test. We want to know the additional variance explained by the interaction. So we'll put our main effects, so that just the predictors, the focal and the moderating predictors in block 1. And then in block 2 or model 2, we'll put in the multiplication term, the interaction term. Now in SPSS, when we run that kind of thing, we get information about our overall model and we get information about our partial f-test, right? In our overall model, we need our f estimate, we need our degrees of freedom, we need the significance level, and then we'll need the confidence intervals and our 95% confidence interval for R squared. So our R squared is there, but then we'll need the R squared confidence interval, which you get at the Daniel Soper website. And then in the rest of this table is our partial f-test, just like in your homework 5. So you have your f estimate, your degrees of freedom for f, for the partial f-test, the significance, and the delta R squared, the change in R squared. And then looking at the coefficients, right? What can we say about those regression coefficients? Well, here for age, it was not significant. So that means the relationship between age and job satisfaction is not significant. For seniority, this one is significant. There was a significant difference in job satisfaction due to someone's seniority. For every 1 unit increase in seniority, job satisfaction decreased, the negative, by 32.307. So people who had been with the company longer had lower job satisfaction. And then here, this is the one that we're paying attention to mostly. Our age by seniority interaction term was significant. So that means that that relationship between age and job satisfaction was dependent on someone's seniority, how senior they were. So it wasn't similar for all levels of seniority. It was different. That relationship between age and job sat was different depending on seniority levels. So let's take a look at the equation again here. Now, job sat is predicted to be 311.41. When? We've always said it's when these things are 0, right? When age is 0, seniority is 0, and this would then be 0, right? But we've mean-centered these terms. So that means that this corresponds to average age, not 0 age. So for participants in average age and in average seniority, their job sat is predicted to be 311.41. So what were the means for these for these two? Well, it's in the notes on the PowerPoint. The mean was about 19 and a half years old. So, and seniority was almost 6 years. So for participants at about 6 years with the company and about 19 and a half years old, that's when job sat was 311.41. So we had always said before how B sub 0, the y-intercept, is when the predictors are at 0. But we changed where the predictors are 0 at when we mean-centered those terms. So keep that in mind. B sub 1 is our main effect for age, right? So if seniority was held constant, a 1 unit change in age would result in a 0.78 increase in job sat. And then same for B sub 2 here. If age were held constant, so if there were no changes in age, a 1 unit change in seniority would result in a 32.31 decrease because of the negative in job sat. However, we already see that the interaction term is significant. So that means these main effects don't really make sense because they're assuming that age and seniority are held constant, when through the interaction term, we can see that there's differences going to happen between these relationships and job sat due to age or seniority being different. They vary across those levels of age or seniority. So that's why once you have a significant interaction effect, you kind of, you do report the main effects, but then you move on to probe and explain the significant interaction effect. And this is why. So B sub 3 tells us that the number of units that the slope of predicted y on x will change for each unit change in the moderator. Let's look at that. So if we're saying age is the focal, I'm looking at the relationship between age and job satisfaction, that this relationship here, the 0.78, will change by this much for every 1 unit increase in seniority. So for every 1 unit change in the moderator, the relationship between age and job sat will change by the B3 amount, by the regression for B sub 3. And this pretty much means that there's a different regression line predicting job sat from age for each value of seniority. So if participants had been in the job 1 year, or 2 years, or 3 years, or 5 years, or 15 and a half years. So it ends up that there's an infinite amount of regression equations there, and we don't want to evaluate all of them. So the way we go about evaluating this interaction effect is we choose 3 values to check out. And typically we choose 1 standard deviation below the mean, and 1 standard deviation above the mean. And we just look at those 3 kind of points along seniority, those 3 values, and saying at what values of seniority is this significant interaction effect impacting this relationship between age and job sat. Okay, there I put in your notes here, there's a helpful website called the Analysis Factor, tips on interpreting the moderation, that seemed a good way to kind of look at it, maybe get another perspective on interpreting a moderation. So in the labs, we're going to probe the interaction, and we're going to use a few different ways of doing that. I picked out 3 options for SPSS and 3 options for R, and some of them are kind of the same to each other. So for what we're going through in the slides here, I'll show you the first one here, running simple slopes at each level of the moderator. And then in the labs, we're going to actually put our hands on trying a few of these. So when we want to get those 3 points on the moderator, the low as far as 1 standard deviation below the mean, a medium, so the mean, and high, 1 standard deviation above the mean, values for the moderator, we have to create those new terms in the data. At least in SPSS we do. So we would have already had our mean-centered seniority when we were running the regression itself. And then to get the low and high-centered terms, it kind of feels backwards, where we add the standard deviation to get the low-centered terms, and we subtract the standard deviation to get the high-centered terms. So we'll run through that in the labs as well. So it would be just computing a variable, and we would take our centered term and then either subtract or add. We subtract when we're making the high centered, and we add the standard deviation when we're getting the low centered term. And then we run the regression with those terms one at a time. Like for this one, if we're considering age, when it's a condition, conditioned on when seniority was low. So what is the impact of age on job sat under the conditions of seniority being low? So that regression would only have age centered, it would have seniority at low, and then it would have the interaction of seniority low centered with age at mean centered in a third row there. But the only thing we're really interested in when we're probing the interaction is this relationship between age, the focal predictor, and the outcome. So the rest of it you can just leave like it's got to be in the regression, but our focal point, what we're interested in here, is the relationship here between age and job sat under the conditions of seniority being low. That's the moderating effect there. So it turns out that significance, nope. Age is not a significant predictor of job satisfaction when seniority is low. So the only information you're pulling out of this probing of this piece, this conditional piece of the regression, is your regression weight for the focal predictor, the t-test, which is right there, and your p-value. So we're not reporting betas on the probed interaction. We're only reporting betas on the overall model back when we saw that the interaction was significant. So now we would repeat this regression for when age at when seniority is high, and the relationship between age and job sat when seniority is at mean. So 3 different conditions: seniority low, seniority average, and seniority high, looking at, do any of those have an impact on the relationship between age and job sat? Right? It's a mouthful. So this provides us, there's the question of what is a simple slope? A simple slope is the slope between age and job sat under the condition of seniority being low here. So this would end up having a conditioned prediction equation that job sat is predicted to be 342.80 plus or minus, since it's a negative, 26.02 when seniority is low. So that's why it's called a simple slope, because it's only got one of the predictors, because you're already conditioned, holding seniority at low for this regression, this kind of post hoc regression. So you would have to repeat this for when seniority is high and under the condition of seniority being at mean. So what does that mean for us on regressions? How many are we probing? Well, 6. We're looking at within age, so when age is the focal variable and seniority is the moderator. So we're looking at the relationship between age and job sat when seniority was low, when seniority was average, and when seniority was high. Then we change it up, and we're going to look at seniority being the focal predictor, and then age will be the moderator. When age is low, what is the relationship between seniority and job sat? When age is average, what is the relationship between seniority and job sat? And when age is high, what is the relationship between seniority and job sat? A few. Now, when we get to the output and going from output to write-up, now you need to start pulling information out of that output. Like we've done before, your overall regression model, so that's going to be your final model. You know, if you only have 2 levels to your model, you have a step 1 and step 2, then I'm talking step 2. But your final model, you're going to report your F statistic, the significance, the R squared effect size, and the 95% confidence interval for R squared. You'll also want your incremental variance that was added into that model by adding in that interaction term. So you have, like your hierarchical regression, you have one step from model 1 to model 2 where you have a partial F test, and you would have the estimate, the significance, and the change in R squared. Your regression coefficients for the final model would be the regression coefficient itself, the significance, the beta, so now you need the standardized regression coefficient, and the 95% confidence interval for your unstandardized regression coefficient, the first one. And then we go into the probe of significant interactions, but there we're not looking to report all of those rows. Once you start probing the significant interactions, you're only interested in the focal predictor, okay? So that's the part that you want to watch with, because you're only predicting that one line that is about the focal predictor's relationship with the outcome. And here we're going to add in the t-test. So you have the regression coefficient for that focal predictor, the t-test, and the significance. Okay. So what did we cover so far? Kind of discussed our setup and what is a moderated regression when we think that the relationship between a predictor and the outcome changes or is impacted by the levels or values of a different predictor in the equation. Kind of took a look at what's coming up with centering the continuous predictor and creating an interaction term. You got a heads up that we're going to be doing a hierarchical regression to see that incremental variance explained by the interaction. And then if the interaction is significant, we have a bunch of regressions to run where we're interested in the different relationship now between the focal predictor and the outcome. And we're choosing 3 values of the moderating predictor to check that out. We're just spot checking 3 values for the moderator. I did leave you a little slide here about process macro. We're going to be using this, and I'll talk about it a little bit more in our lab. It's an add-on, so you have to download it and incorporate it into SPSS or R, and that's going to depend on if you have administrator access to SPSS, which I'm sure anyone using SPSS through Argo apps, you don't have that, but that's okay. That's why we're running the probe of the interaction with different options, because you're not stuck with only using process. Now, once we get over to R, you can run process on that because you do have all the rights to R and R Studio since it's free anyway. It can be a little bit to get started in it, but it's actually the easiest one to use if you can just get it working on your system. But we'll look at it in the labs. So, hi class, welcome back. We're going to start with our lab in SPSS. And this last lab of the term involves examining the interaction effect between 2 predictors. In other words, does the predictiveness of predictor 1 depend on the values of predictor 2? Or is the impact of our focal predictor dependent on the values of the moderating predictor? We're going to have some new skills going on, getting our continuous predictors ready for the regression, creating mean-centered terms and interaction terms, and identifying some information in the output to report, and really doing a lot on probing interactions, because I have a few different options for you to check out in our lab. You need your lab sheet, which is this document, the annotated output, and the data set called lab6.sav. Now in that data set, there's only 3 variables. There's job sat, age, and seniority. So we're just going to keep it nice and simple here for the lab. Again, I'm not going through the preliminary analyses. You would get your general description of the data set and variables of interest, do your univariate assumption checking, and your multivariate assumption checking for like homeworks and stuff. But for the labs, I'm just having us spend our time on running the analysis itself. Now we are going to need the mean and standard deviations for the predictors, so I will request that for our study variables. Go to Analyze, Descriptives, and I want all 3 of them over there. There we go. And be sure you paste and run from syntax. So I have that my average job sat is 318. The average age for participants is 19.5, and average seniority is, if I round, it's 6.0. So next on our lab sheet, we want to create the mean-centered predictor variables. So for that, you're going to go to Transform and Compute Variable, and we want to take the variable minus the mean to have our mean-centered variables. So I'll show you how that's done. We go to Transform and Compute Variable, and you'll get your setup here. And here you want to give a name to your centered variable. I used, look at my syntax here, age mean centered. So you're going to give it a name. And then you want to give yourself a label so that you can keep track of things. Age mean centered. And hit continue there. And what I want is age minus the mean. What was the mean? We just pulled it. And if you double click in your table and get it to open up like the pivot table thing, you can get like the whole number there. So I'm going to copy that and then go and paste it. So that's going to be my new variable of age mean centered. So paste and run from syntax. And then I have a new variable here that's age mean centered. And then now that you have that coding in your syntax, you don't have to do all the click through all the time. You want to create a mean centered for seniority. So that's the name of the variable. That's the actual variable in the data set. Spelled wrong, seniority, okay. and then the mean that we can get from the descriptives we already ran, right? 9818. And on the syntax, I used the longer one, 981818. Is that what it is? I want to make sure now. Yeah, 1818 when you get the whole number. Okay. So then you can compute the next one just based on syntax. You don't have to go through the click-through each time. Here's where you assign the label. Like that's the new name that I gave the variable, and then I have to use that new name giving the variable the label of seniority centered at mean. So I can run that guy. And then the interaction term, very similar. I'm going to give it the name of age MC times sin MC. That's just the name I gave it. But it's going to equal the two variables I just made and multiplied in between. And I can give it the label. And notice that my label is in between single quotes there with a period at the end. So then run that guy. So there's my two new mean-centered variables and the interaction term. Now you can do the click-through anyway. You would just go through each one and compute variable each time and give it a label and stuff. But now we're ready for model testing. So we're going to do the hierarchical regression like you did in our prior module, because we want the interaction term in the second block. So I'll go to Analyze, Regression, Linear. I'll put the main effects, in other words, the two centered predictors, in block 1, and I'll put the interaction term, the one that's multiplied, in block 2. And then I have a couple other things we want to ask for in statistics. So Analyze, Regression, Linear. In here, job set is my dependent variable, and I want my main effects of the focal and moderating predictor here, the mean-centered ones. And then next, for my next block, I want the interaction term in block 2. In statistics, I'm going to want confidence intervals and R-square change and the covariance matrix. We'll use that later as one of our options for probing the interaction. So I think that's all I need there. Cool. And I'm going to hit continue here. I'm just going to check options to see if there's anything. Nope, don't need anything there. So paste and run it from syntax. And we can look at this. Dependent variable is job sat. On the first block, it's age mean-centered and seniority mean-centered. And the second block, it's age by, it's the interaction term, right? And I asked for that B-cove right there is the covariance matrix. The change is the R-square change. Yeah. So I'm going to run that, and then we'll go take a look at this output here. So like I was talking about on the lecture video, when you're looking at the overall model, you're looking at model 2. You're looking at the one with everybody in it. And that's where we get our F-stat line, our degrees of freedom for the overall model, our significance for the overall model, and model 2 here is your R-squared. But we needed to run model 1 just so that we could get the rest of this information here. It's still on the model 2 line, but it's saying the amount of change in R square that happened when that interaction term was included. And because it's a significant F change, partial F test, that means the interaction term itself was a significant contributor. And we can go ahead and see that in the coefficients down here. That we're looking at model 2, that all else being zeroed, which means mean centered here, the job sat would have come in at 311.408. But we have that age is not significant. The mean effective age is not significant. We still report it, but it's not a significant contributor to job satisfaction. Here, seniority is a significant predictor. And then the interaction term is a significant predictor of job satisfaction. And it's because that's a significant predictor that we go into probing the interaction. Like I said, we'll come back to our coefficient correlations when I think it's option 2 that I'm giving you guys for probing the interaction. So we'll come back to this table in a little bit. Okay, so the overall model is significant, including the interaction term contributed to a significant increase in the variance explained. According to the coefficients, age is not a significant predictor, but seniority is. And with the significant interaction term, we're going to move along to probing the interaction. Now we can go ahead and write the regression equation because it's built from the final model here. When age and seniority are at average, expected value for job satisfaction is 311.41, and that's our regression prediction equation. Okay, so probing the interaction. I have several options I want you to try out here. They have different pros and cons, but they all give you the same information. So for option 1, we're going to evaluate simple slopes, and our focus is on the focal predictor to determine if it's still a significant predictor of the outcome at 3 different specified levels of the moderator. And that's the one we kind of looked at in the lecture. Option 2, we're going to evaluate covariances between regression coefficients, and that uses an online calculator. But we have to do some things in SPSS to get there. And then the third is that add-on called Hayes process macro, and that we have to jump through a couple of hoops to get it started, but it's actually super easy once you have it working on your system. So starting with option 1, simple slopes regressions, we're going to make some more variables. So we need to represent the moderator at low centered, at mean centers, and we already got that one, and at high centered. And what I mean by those is 1 standard deviation below the mean for low centered and 1 standard deviation above the mean for high centered. We'll start with seniority as being our moderator, and we'll have age as the focal predictor. So I want those 3 levels of seniority. Seniority at average, seniority 1 standard deviation below the mean, and seniority at 1 standard deviation above the mean. And it's really important to keep track of who's who here. So you want to name your variables well, and maybe have a little cheat sheet on the side on who's your focal and who's your moderator as you're going into these. So like I said, we already mean-centered seniority, and we called it SEN-MC in the syntax. So now we're going to get a low-centered seniority term, and to get that, we add the standard deviation of seniority to the mean. I know it sounds weird that we add value and it becomes the low-centered one, but it works out that way. So we're going to go to, you can do the click-through, transform, compute variable, name it SEN-LC. The variable would be low seniority, 1 standard deviation below the mean. And the numeric expression is going to be, because we want to get that is our standard deviation. So if I go back to our output here and scroll back up to where we got descriptives, the standard deviation for seniority is right there. And that's the one we're going to be using to add and subtract to the mean centered one. Okay. So I'm going to transform and compute variable. I'm going to call this one SEN low centered, and the label, spell it out to yourself so that when you get it in the output, you know which one it is. So continue there. It's going to be seniority at average. I want low centered, so I'm adding the standard deviation for seniority. Copying that and putting it right there. So paste and run it from syntax. And now we have seniority low centered right there. Now I also want to get one standard deviation above the mean. So there I subtract the standard deviation. So you can either do the click-through or you can just adjust your syntax and run it from syntax. And then I still need, let's see what I do next. Now we need the interaction term between age at mean, because that's my focal. Leave the focal variable at mean centered. It's only the moderator that you're changing levels on. Okay, you're going from low, high, and average, right? So we need two interaction terms. We already got the interaction term before for average age by average seniority. So we already have that one in the data, like right there. That guy. Interaction of mean centered age and seniority. Right? And that's when we ran the first regression. But now we're going to need an interaction term for age with low centered seniority and age with high centered seniority. And we can do that by either doing the click-throughs or copy pasting your syntax so that you always check and make sure you have the ones that you want and they're labeled. So now there's my interaction terms that I need. And this is how you do the click-through if you want to follow that. Okay, so now I'm ready to actually run these regressions. We're going to first look at the relationship between age and job sat under the condition of low seniority. So I'm going to set up my linear regression and have low seniority as one of the predictors and the interaction term with low seniority. And it's only going to be in block 1. We're not running hierarchical here. It's just one simultaneous regression. So I'll do the click through for the first one so you can see it. We'll do analyze, regression, linear. We want job sat as the dependent variable, and we want age at mean, seniority at low, and age by seniority low. All three of them. And then, did I ask for stuff? I think I need all of this. I definitely don't need R squared changed. I don't think I need confidence intervals either. Yeah, because all we want here is the, we're only looking for the line for the focal predictor here. So we don't need a whole lot of extras on that. So paste and run it from syntax. Here's the one for low, and that's what it looks like. My dependent variable is job sat. I entered age at mean, seniority low, age by seniority low. And now let's take a look at this. We're not even worried about the overall summary at all. We're only looking for what is this relationship now between age, our focal predictor, and the outcome, job satisfaction, and under this condition of low seniority. We see that it's not significant, and the information we need out of this table is going to be the regression coefficient, the t-test, and the significance. So now we have 2 more to run. We want to know, under the condition of average seniority, what is the relationship between age and job sat? And again, we're just skipping over the main model and we're coming right here to our focal predictor. At average age, when seniority was average, is not significant. We need our B value, our unstandardized regression coefficient. We need our t-test, and we need our significance value. And then one more, where age is the focal, under the condition of high seniority, we'll look at these. Again, going straight to our coefficients. What is the relationship between age and job sat under the condition of high seniority? So it looks like it is not significant. There's our unstandardized coefficient, our t-test, and our significance value. So no matter what seniority was at, age was not a significant predictor of job satisfaction, right? So now let's look at, now we have like a whole nother half to do. We're going to switch it up and have now seniority is our focal predictor and age is the moderator. So I want to know the relationship between seniority and job sat under different levels of age. So I want like a low age, one standard deviation below the mean. I want to know average age, what's the relationship between seniority and job sat, and then I want to know high age, so 1 standard deviation above the mean, what is the relationship between seniority and job sat. So now I need to make some more variables, but you can just copy from what you had before. You just gotta watch what you're doing, right? I need age at low centered, which is the age mean centered plus the standard deviation for age. And then give it a label. Age centered at 1 standard deviation below the mean. That's where we put its value at. And then an age at high centered is going to be the mean minus the standard deviation. So getting those guys. And now I need those 2 interaction terms. The interaction term between my focal predictor, seniority, and low age, right there. And another interaction term between average seniority and high age. So give yourself good labels and you can run it. And now I have all of my new variables there in the variable list. Age centered 1 standard deviation below, 1 above, and the interaction between those sets. All right. Now we're ready for the second set of regressions. Like I said, we had 6 altogether, but they go fast when you just use the syntax and adjust the things you need to. You just got to watch out for every little dot and tittle though. So here's our 3 regressions, one for low age, one for mid age, and one for high age. And saying, is the impact of age significantly moderating the relationship between seniority and job sat? So I'll run all 3 and then I'll go to the first one. That's high, that's average, and here's low. So you can look at your syntax. Typically you can look at your syntax in the output. If you're not getting your syntax in the output, it's just a setting. If you go into options, you can tell it to report the syntax in your output. So here's the one for low age and average seniority. And again, I'm just going straight to the coefficients table because all I'm interested in is the focal predictor of seniority. What is its relationship with job sat, and is it significant? So it's a significant relationship, which means under the condition of lower aged employees, seniority was negatively predicting. So it's got employees would have less job satisfaction when they're young employees, and seniority was around average. Remember, around average for seniority was around 6. Average seniority was around 6 years. And then for the younger aged employees, this was a significant predictor of job sat, and not only a significant predictor, but a negative one. So employees had less job satisfaction. And that number changes the relationship between seniority and job sat. So it changes the B, I think it's B sub 2. And then the other ones we're not after. So now let's look at the coefficients for average. So average age, average seniority, we're only considering our focal predictor there. So at average age, seniority was still a significant impact on job satisfaction. And this is how much the interaction term gets changed, or not the interaction term, the regression coefficient for seniority, that relationship between seniority and job satisfaction, that's how much that changes. And that's the only piece of information we want: our unstandardized regression coefficient, the t test, and significance. All this other we're not after. And then one more to consider for probing the interaction. Under the condition of high age, what is the relationship between seniority and job sat? Well, it's still negative, but now it's no longer significant. So at high age, seniority is no longer a significant predictor of job satisfaction. Okay. So that's one way to probe that interaction. And that's what you're looking at, is 3 points on the moderator. What is the change in relationship between the focal predictor and the outcome? So that's why you might want to write it down. When age is my focal, what are the 3 levels of seniority and how do they relate? How does age relate to job satisfaction at these 3 different levels of seniority? And then when we turned it around and seniority was the focal predictor, now I'm looking at the relationship between seniority and job sat for 3 different conditions of age. So let's go look at our option 2 now. A covariance matrix. We're going to go back in our output to that covariance matrix that we asked SPSS for before, and use this option for considering the interaction effect. And what is covariance? Covariance between the coefficients itself is kind of similar to correlation. It's saying how much do those regression coefficients covary together in this data set. And this is an advanced concept, so if it feels like, ooh, that's a stretch, that's okay. That would be normal. Covariance matrices would be the beginning of your like next stats class, like on multivariate analysis, and it's the foundation of structural equation modeling. So it's kind of past this course, but I wanted to show you how it's done, and especially since we have like an online calculator to help us out. So the information, we go check out this Preacher's Online calculator here. There we go. So you get to this page, and let me bump it up a little. That should work. And then you got to scroll all the way down to the calculator. There it is. So this is our equation: predicted outcome, the y-intercept, the regression coefficient for the first focal predictor, the regression coefficient for the moderating predictor, and the regression coefficient for the interaction term, right? And we have a lot of information that it's asking for here. So the coefficients themselves, the coefficient variances, and the values of the moderator, some points to plot, and so on. So we're going to work through these on our lab sheet here. So over in here, this is just a little list of the things that we already have on that. See if I can move this over a little bit, and we'll bring this over so we can see it together. And I just gotta minimize a little bit. There we go. So we already have some information to be able to fill in that. And where did we get it from? Let's go to SPSS and to our output and scroll way back up to that covariance matrix we asked for right there. Coefficient correlations, that one. So looking down here, we want model 2 because it's the one with everyone in it, and this is back to our overall model, right? And what we have, like, here's seniority by seniority. Well, the covariance of one thing to itself is the variance. So the variation, I think we talked before about how variance is the standard deviation squared for terms. Like if we were talking back at our descriptive statistics, if I took the standard deviation of seniority and I squared that, that would be the variance of seniority. Well, we also can get variance of the coefficient itself. So this is the variance of the seniority coefficient, and it's seniority by seniority. Variance is along the diagonal, and then the covariance is going to be off diagonal. So the covariation between age and seniority is right there, -28,733. And remember, age was our first predictor, so it's B sub 1. Seniority was our second predictor, so it's B sub 2. And then B sub 3 is our interaction term, right? So there is information for filling in. Bring this way. This guy right here. So the coefficients, those we got off of the overall model. So the model results The y-intercept was 311,408. The age was 0.781. So those were off of the model results. And then our variances right here, the variance of seniority to seniority is 194,296. And seniority was B sub 2. So I put it there to help me keep track of it, even though it's not necessarily in the right order in this table. And then the variance for age to age right here is 139,885. And I put it in B sub 1 because that's what age is, B sub 1. And then the coefficient for the interaction term, B sub 3, the variance would be the interaction term by the interaction term right there, 132,670. For the covariances, see this one with B sub 3, that's the interaction term, and B sub 1, which is age, I can find that one on here because here's age and here's the interaction. So the covariance between the coefficient for age and the coefficient for the interaction is 25,791. So I put that one there. Now, what we don't have the variance for the y-intercept. It didn't give us that. And because we don't have that, we don't have the covariance between seniority coefficient and the y-intercept. So to get those, we're going to have to trick SPSS. It's for it to give it to us. But let's go ahead and look at these last two pieces, or these last few pieces, before we go tricking SPSS. The moderator, and you'll notice that in the Preacher website, they call the moderator Z, whereas I was calling it M. So just keep track of that here, moderator is considered Z. And what we wanted for the moderator was one below the standard deviation, or one standard deviation below the mean, and one standard deviation above the mean. And we're mean centered, so we don't have to calculate it out here. We just got to make sure we put those values into here. Like this would be this guy. For that. And this guy without the equal mark for here. Just gonna take that off. And then the mean is just going to be 0 because the predictors are mean centered. And then, so we have a lot of information. The degrees of freedom, they tell you the degrees of freedom in the output, but it's going to be your sample size minus how many predictors you have minus 1. So for us, the degrees of freedom is going to be 51. That goes here. And then the 2 points in predictor space. So their predictor, right now, we're seeing that age is the focal predictor. And if we want a couple of points, we can just go ahead and use one standard deviation above and one below. Those are perfectly good points to use. So again, getting that standard deviation helps you add some points in here. We know that they're at least one standard deviation from the middle. Here, and all I need is to take off the negative sign. There we go. So I need to fill in these other things. Might be faster for me to type. There. Yeah, if I just tab, I can type. So 0.781, 32, negative 32.307, and 27 0.578 for the interaction. And then if I tab, it goes right up to coefficient variances. So I don't have that one yet. I'll get it in a sec. 139.885, 194, oops, maybe it's not faster for me to type. 296 and 132.670. Cool. Okay, so I need that guy. I need this one. This one I have 25.791. Okay, so that's all I can fill out yet, because I have to go back and trick SPSS into giving me the information related to the y-intercept, the b sub 0. So how do we do that? So we need the variance and the covariance related to the intercept, and that output was only giving us the predictors. So it's not considering the y-intercept as a predictor, right? So what we need to do here is we need to create a new variable called c. We're just going to name it c, and we're just going to give it a value of 1. And this is so we can add something into the regression equation that doesn't change anything, because anything times 1 is just itself. And we're going to use that new term to replace our intercept term. And then we'll run the main overall regression, because that's really the one we're interested in here, that has the predictors, the intercept, and the interaction term. And we're going to work through this. So let's make the C term first. For that, you're going to go to, you can do transform, compute variable, or you can use your syntax. But I'm just going to make a target variable called C. And it's going to equal 1. That's it. So paste and run from syntax. Oh, I gave it a name, constant equals 1, when I did it before. And now I'm going to rerun that model with all the predictors and the new constant variable. I'm going to request the covariance matrix again, but I'm also going to go into options and uncheck the box that says include constant box. I'll show you what that looks like. So we're going to analyze regression linear. And what I want here, my dependent variable, my centered age, centered seniority, my normal interaction term, and C. So I'm adding that new variable into my predictors here. In statistics, I'm going to make sure I ask for the covariance matrix. And then in options, I want to turn off of this, because it's adding that constant, like that's why we get the y-intercept on our regular stuff. We're going to take it out because we've added it manually here. So we don't want SPSS to add it again to the model, then it would be in there twice. So I'll hit continue. You want to paste your syntax and run it from there. And let's see what we got now. Okay. So see, we got the same the same information, right? The constant is now taking the place of the y-intercept. But it's still 311.408, like it always has been. All of these did not change, and that's important. If it changed, you ran something wrong. But now we got this coefficient correlations down here, and we have the constant. We have the covariance of the constant to the constant, right? You got to find where they match. And that is the variance of B sub 0, 170,256. So I'm going to get my 170,256. That's this guy. 170.256. That's my variance of the y-intercept B sub 0. But now I want the covariance between the intercept and seniority, B sub 2. So where do I find that? I want the constant, B sub 0, and seniority. Right there. Negative 8.850. Negative 8.850. Cool. So now we have everything. We have everything on this little calculator here to do some stuff with now. So I'm going to hit calculate, and what it spits out is down here. And again, this was an option for evaluating the interaction. In this option, we didn't have to make a low and high centered terms for age and seniority. We just plugged the covariances and the variances into this calculator. So first it tells us kind of what we already know, what we plugged in, what the intercept was, like all of this is information we already had and that we gave it. So here's the values. The simple intercepts and slopes at conditional values of z. Z is the moderator. So when the moderator for us was seniority here, right? There's the intercept and there's the simple slope. And there's the t-test and the significance. So that's what we were getting. That's when I would say, hey, just go down to what is the relationship between the focal predictor and the outcome at this condition? Well, here at this condition, this is the relationship between age and job sat. There's our t-test and our p-value. At average, this is right here's our regression coefficient, t-test, and p-value. And you see not significant, not significant, not significant. And this was when age was our focal predictor and seniority was the moderator. Now, one thing we can do here, we can submit to our web. Oh, that's okay. There we go. I'm going anyway. They need to update their website, huh? There we go. So it ran it and it gave me a plot. So there I have when seniority was low is the black line. When seniority was average is the red line. And when seniority was high is the green line. So age did not have a significant impact, but seniority is like all over the place. The direction of the impact is different according to seniority, but it did not have a significant change in the relationship between age and job sat. And okay, and I'm going to leave that there for now. And we go back to our cheat sheet here. Okay, so that's a second way to look at those probing of the interaction. So that's back to when the interaction came out significant on your overall model. Now we need to probe that interaction. So this was option 2 on probing the interaction. So one more we're going to do. Option 3, using Hayes process macro. And this is an add-on to SPSS. So you would have to install it. And if you don't have administrator access on your SPSS, like if you're running through Argo apps, this won't work. So you can either try running from syntax, but I would say skip this part if you are on SPSS and you don't have administrator rights on SPSS on your computer. But for everyone else, try this out. Hayes process macro, you would have to kind of download it first. So here's the website to go to learn about it. And it starts just telling you about it and his different just testimonies and books and stuff like that. But what you're looking for here is download. Oh, there it is. So download, and it's got a little disclaimer, and then your downloads at the bottom. So when you download that, it's going to drop a zipped folder into your downloads area. Like that, process 4.0 zip. And when you expand that zip file, you'll have a process folder, and it's got some information in PDF form about his workshops and syntax guide if you're going to use the syntax, because you can do that instead of installing the it's called custom dialogues, but it's way easier with the custom dialogues. So in process 4.0 for SPSS, you'll have the syntax, and you'll have just this is the macro right here. Process SPD is what you're after there. So here I have it right here, unpacked and ready to go in my downloads folder, right? All I did was download and unzip the folder so far, right? And this is the one I'm after in the custom dialog builder file folder. So I'll go back over to directions here. So here I need to know where I've downloaded the SPD file. It's right there in my downloads, right there. Open SPSS. You have to open in admin mode if you're on a PC. And then I'm going to extensions, utilities, install custom dialog. So what that looks like is up in extensions, there's a side one called utilities, and then you follow that down to the last item that says install custom dialog. And when you're there, you navigate to your downloads or wherever you put that file, and go to your process folder, custom dialog builder, to the process SPD. And when you open that, it's then ready to roll. And what you're going to see as a change is when you go to Analyze and Regression, now you have this item that says Process 4.0. That's what that gives you. So I'm going to go ahead and open that, and here I have my dialog box. I can put job sat as my dependent variable, and the X variable is age, that's my focal predictor, and my mediator is seniority. Not mediator, moderator. Moderator right here on W. Some other things you want to pay attention to, this is model number 1. It always opens on 1, but if you change it, it might open different. So you want model number 1. You want pretty sure it's in options. Yeah. So we want the, let me check my cheat sheet here, make sure we get all the things we want out of this. Model 1, job sat, focal predictor, moderator. Gotta spell it wrong since it's spelled wrong in the data set. Now notice we're using the regular non-centered predictor terms, right? So we could use process macro here to run the whole analysis and never even have to make centered terms at all. But in options, what we want is a few things. We want the covariance matrix. Let me move this aside so I can see the tips. Covariance matrix. We want to generate some code for visualizing the interactions. And we want mean center. There we go. Mean center for construction of products, all the variables that define it. In the probe interactions, we want to put it to one below the standard deviation, the mean, and one above the mean, one standard deviation above the mean. That one. That's all. And then we'll hit continue here, and then here we're not going to hit paste. That's right, process does not run from syntax. It will only run from the dialog box or that other syntax file that they made available. So this is what we need here, and we're going to hit OK. And now it provides, well, it's thinking about it for a while, so it's running. It takes it a little bit to run it. But now we have all of this. It's labeled matrix, and this is all the output for the whole regression. So that's why it's kind of easy once you can get it working, you know, it really does everything. So we have we know that our Y was job sat, our predictor focal is age, our predictor that is the moderator is seniority. The overall model, so we got the R, we got the F stats line, the degrees of freedom, the significance, the R squared, all right there. We have all of the coefficients and their significance. We got the interaction term. And then there's the covariance matrix if we wanted to have that information. Here, tests of highest order unconditional interaction. This is the partial F test. So we could have run process for the whole thing just right then. It got everything. It got the overall model, it got the partial F test, and it has the conditional effects of the focal predictor at values of the moderator. So it's got all of the output right here. It's just picking it out. We got our partial F, the degrees of freedom for the partial F test, the significance for the partial F test, and the R square change for adding that interaction term in. Here in conditional effects, we have at different levels of seniority, what is the coefficient for age for these different levels of seniority. One standard deviation below the mean, and one standard deviation above the mean. So this is the t-test and the p-value and the regression coefficient for age relationship with job sat at this level of seniority, at the low seniority. So have all of that right there. And then if we want to get a graph, we got to double click to get in here. We can take everything from data list free through seniority and copy that and go to your syntax file, and you can paste it in. I already did it before, but paste. You can take all of that and run it. It's running graph. Here we go. So it's similar to the one we saw from Preacher, but it doesn't have the lines drawn in. So you got this, the blue, which is seniority at the low. You got right across the middle, which is seniority at mean. And then this with the red dots at seniority at high seniority, the relationship between age and job sat. So it gives you some graphs that you can use for your figures. Alrighty, let's take a look at where we're at on the sheet here. Okay, we're to reporting. Bring that back over. So just a little tips here about reporting your regression. You want to, on a normal regression, you're going to do your summary statistics and all your preliminary analyses, stuff like that. You do include your interaction term in your correlation table. And that is just something that some industries do and some don't. Do it for the homework associated with this moderated regression unit, but it's getting more often that journals want you to also supply the relationships between the interaction term and the rest of the terms, because it's a way of being able to identify if someone's falsifying the data and they can check it quickly. When you report your model test, you want to make sure you include the test that was conducted, which variables, and so on. And generally choose your graphs or figures when they help communicate your results. Typically, I don't include my regression prediction equation in normal write-ups, but we do it for class to kind of help nail that down. And the other note, notice that we really added a lot of new skills on this one with mean centering and creating new variables for one standard deviation above and below. So you want to be aware of how you can probe interactions differently so that you can get to that information no matter what type of system you're on. And the covariance matrix, that is beginning advanced stats stuff. So I'm not expecting you to fully understand all that or have to communicate about it. It's just an initial exposure. And then next on this write-up is a example of what the model testing results might look like. So let you play with that. And then next we'll go into our R lab. Hi, and welcome back. We are going to run through our lab in R Studio. And the things I have open right now are the Lab 6 R script, and I will be loading up our data set. So what you need for Lab 6 is going to be the data set called lab6.dat. And so far the packages we're using are going to be tidyverse and lmbeta and reghelper. We're also going to add in the Haze process macro a little bit later, but that's not exactly a package you load. It's a little different. So first we're going to read in the data frame. Navigating to Lab 6. There we go. And it's a DAT file, which means it's tab delimited. There we go. And they're all continuous, so we don't have to set any factors or anything like that. And I just called it Lab 6. I have 55 observations of 3 variables. That's good. And again, descriptives and univariate assumptions are shown in prior labs, so I'm not going to do them here. We only have continuous predictors, so normally you would check your normal distribution and bivariate linearity and multicollinearity when you're doing correlations is a good idea. And then we are going to need our mean and standard deviation for the predictors, so I'll go ahead and pull those. I wrote myself a little script to make a item in the environment. It says make me something called L6 describe, signed by lab 6, then summarize some new items. These are the variables that will be in it. Average JS, which is going to be the mean of job sat, SDJS, which is going to be the standard deviation of job sat, and so on for age and also seniority, which in this data set, seniority is called just senior. Like you can see the names of the data of the variables there. So now we go into model testing, and to prepare those predictors for running in the regressions, I want to center them. So I already have the mean for age because I just asked for it there. So mean for age and the mean for seniority. And those are what I need to use to compute the mean centered predictors. So I'm going to add a new variable to lab 6 called age C, and it's assigned by the lab 6 age variable minus that number. And likewise, I'm making a new variable in lab 6 data frame called senC, and it's assigned by the lab 6 variable called senior minus that value. So run both of those. And now my lab 6 has extra variables in it, HC and senC. So this goes to, now we're ready for that hierarchical regression because I want the partial f-test, right? So I'm running the first model that only has the centered predictor terms, the focal predictor and the moderating predictor, and that'll be model 1. And then here I'm saying this one's going to be lab 6 M2 assigned by the linear model of job sat predicted by HC times senC. And remember, that's how we would make a interaction term, right? Is to multiply them. But here I'm just putting the multiply right there in the equation and running from there. Let's take a look at what that did. So, and I can go ahead and grab the confidence interval too. So let's take a look here. Output check. I have the full model, the f-stat, the degrees of freedom, and the significance value. I have the R-squared effect size. And then even though I only put the multiply, it still gave me the main effects for HC and senC. So I didn't have to put HC plus senC plus HC times senC. I could, it still would be the same output. But all I had to do was put the multiply and it put the main effect terms in there anyway. So there's my estimate. I know that age, according to the p-value, is not significant, not a significant predictor of job sat. Seniority is a significant predictor, and the interaction is a significant predictor. So I have a couple more pieces of information that I would need for the main model. So I'll go ahead and grab them now before I move on to probing. So I need the partial f-test, right? I called for model 1, but I have to compare it to model 2 to see if that change in f or the change in R squared is a significant change. And just like we did in our prior homework, we're going to use the ANOVA function to evaluate that. So the ANOVA between model 1 and model 2, and it tells me right down in the console that my F test is right there. My degrees of freedom are going to be 1 and 51. And the significance value is 0.020. So that's what I need to write up the partial F. What I still need is the change in R squared. So just like we did before, I can get R to like calculate it for me. I can set a new item in the environment called RS1, and it's the summary of the model 1, but specifically the R squared value. And then I do that same thing for model 2, and then I just tell R to subtract them. I could just get a calculator out and do it as well, but I'm being lazy, and I already have the code, right? So my change in R squared is 0.086, about 8.6% increased variance explained by the interaction term that I included in model 2. And for that final model, I'm also going to need my standardized regression coefficients. So I can go ahead and get those and have those as an item in my environment using the function from LM beta. And I can get a look at them too, that my standardized coefficients for each term, because I'll need that beta value when I'm reporting the overall model. Okay. I think that's all the little tidbits I still needed for the overall model. Now let's go back to our model testing. That interaction term was significant. So time to check out the simple slopes. And what are simple slopes? Again, it's looking at the relationship between your focal predictor and your outcome at conditioned or constrained to certain levels of the moderator. And that simple levels of the moderator that I want to try out are 1 standard deviation below the mean, and 1 standard deviation above the mean. Those are the 3 places of the moderator that I want to check out, and I want to see what's the relationship between the focal predictor and the outcome at each of those constraints. So option 1 that I have for us in R, found a pretty straightforward option with the package called Reg Helper. So we're going to run that. And whenever you have something, a new package that you want to check out, you can also check it out in the help menu over here and see what it has going on, right? So it's got just a few functions. It's not, long, but one of they got beta, they got build model, ICC, graph model, that might be cool, and simple slopes. Easily calculates simple effects of an interaction. Okay, sounds good to me. We can follow that, and it even gives us how the syntax might run. So the model, the levels, sometimes they give an example at the bottom. So for a linear model, they gave this example where their linear model was miles per gallon predicted by weight by whatever AM is in this data set. But then when they did simple models or simple slopes, they just used the function simple slope and then put the name of the linear model in parentheses, right? So I can do the same thing, simple slopes and the name of the model in parentheses. So let's check this output. So see the SS test right here? We got age centered, we got seniority centered, we got test estimate, standard error, the t-test, degrees of freedom, and the p-value. And so when we look in this, see how we got SS test 3 times here and then 3 times there? In this first 3, we have age at the 1 standard deviation below. We have age 1 standard deviation above, and we have pretty much 0, because 1 to the negative 0.6 zeros is pretty much 0. So this is acting as, this first 3 show age as the moderator. So that's 3 different points of age if seniority was the focal predictor. And that's not what we were gauging towards, but I have all the information right there for both if I was considering age as the focal predictor or seniority as the focal predictor. And I have all the t-values and everything for both of those sets. So those 6 regressions that we ran in SPSS, one at a time, making centered and interaction terms for each level, it's all right there, all in one set. This 4 through 5, these last 3 regressions that were run, this is when seniority was at low, so 1 standard deviation below the mean. This one's the mean. This one's 1 standard deviation above the mean. So looking at that, when under the condition of seniority low, age is the relationship between age and job sat. So the predictor, focal predictor right there was negative 26.06. Here's my t-value for that run and my significance. And then same for medium or mean. And here's my information for when seniority was high, what was the relationship between age and job sat. And you see that none of these last 3 are significant. That one's marginal because sometimes people report p less than 0.1 as a marginal significance. You check with your industry on that to see if that's something they want. But here in the first 3, when seniority was the focal predictor and age was the moderator, this is the relationship between seniority, the focal predictor, and the outcome job sat. And it looks like when age was young, it was the younger age, it was a significant relationship between seniority and job sat. Also, when age was average, right here, the middle one, there was a significant relationship between seniority, the focal predictor, and the outcome job sat. But when age was high, there was no significant relationship between seniority and job sat. So I felt that that one's pretty straightforward. Option 1 there, Reg Helper. That we saw in the output about, or in the help file about graph model, that looks cool. I wonder how hard that is. Uses ggplot2, which we use. Graph model. When we're using a linear model, so the model, the y, the x, those are none. Error bars if you want them. We can try that. Let's see what it does. We would do, oops, if I can spell, graph model. The model was L6 M2 Y, oops, equals job sat. They never asked for, no, they asked for the model. Okay. X, I'm wondering where do they ask about the moderator? X, if I'm saying that age is the predictor, we'll do X equals age C. Let's see what that does. Not exactly what I was expecting. Okay, it did age. So it's really that I want seniority there, right? So let me try that. That's better. So at different levels of seniority, there's differences in JobSat. But anyway, I'm liking some of the other graphs we get, but it's an option. And maybe it's got, when you saw in the help file, it's got other things we can put on there. So let me Mermod. Oh, it's an idea. It did run and get us the interaction information quickly, like right there. That's all of it. That's pretty cool. So option 2 is using Preacher's website calculator like we did in SPSS. But what we would need from R is the covariance matrix, just like how we had to trick SPSS to get the covariance matrix and get it all together. We're going to look for one here. So sometimes you can come into help and just say what you want. Covariance matrix. And see what it pulls up with. This is anything that had the string covariance matrix in it. So looking down, this one called stats, that package is a base package of ours, so you don't even have to add anything new. So let's go check out that, because it says variance covariance matrix for a fitted model object. And that's what we have, is a fitted model. We go there. It says just do vcov object. And you can use it for some other things. Okay, and we'll try that. vcov of my linear model, model 2, that has everything in it. And let's see what it did there. So there's that covariance matrix again, but you notice that it gave us the variance for the intercept, which we had to trick SPSS to do. So if we go to this and scroll down to our calculator, oh, I can move this like this. Bring this guy in. Oh, that makes it jack out. There we go. There we go. So I want the intercept variance. When it's to itself, it's the variance. When it's across, like this is the intercept to age C, that's a covariance. So very similar to your correlation tables. So that's a variance for age C. No, variance for the intercept right there. For age variance, for seniority variance, seniority to seniority, that's the variance of the coefficient for seniority. And now I need the one for the interaction right there. Next, they want, oh, those were the coefficients. Put it in the wrong place. All right, let's go back and get the coefficients, which I can get through summary of Lab 6 M2. So there's my intercept. That's what was supposed to be here. And I need to get my negative because it didn't grab there. So negative and then paste. Copy and paste. So I got those. My conditional values of z. So if age is my predictor, focal predictor, and seniority is my moderator, then what I want is the moderator. Let me get the descript. I want plus and minus 1 standard deviation of the moderator, and the moderator's seniority. So I'll put a negative here for that one. I'll put a 0 because this is mean centered, and then I'll put a positive standard deviation there. Similar for points to plot. This is talking about age now. Where on the age predictor space do I want to plot? Well, I'll go ahead and plot 1 standard deviation above and 1 below the mean. Just because might as well be some numbers. You can put any numbers as long as they're above and below. They're apart from each other so that you can have 2 points on your plotted plane. Degrees of freedom, again, they do give it to you right here, degrees of freedom, or if you need to calculate it, it's going to be the sample size minus how many predictors you have minus 1. So my sample size is 55, minus 3 predictors would be 52, minus 1 would be 51. And then I need my covariances. So this is seniority and the intercept right here. Intercept and seniority. And I want the interaction term, B3. It's the interaction coefficient and the age coefficient. So age and the interaction right there. All right, do I have it all in correctly? Got my coefficients, the variances, the covariances, where it's getting plotted at, and degrees of freedom. So I'm going to calculate there, and we have the output, what we put into it, basically. The simple slope for each level of the moderator. And the points to plot, like you can actually tell R to plot specific points on a graph. It takes a little more doing though. We can also just like take all this and copy. So Control A for all, Control C for copy, and then go right over here into, we can go into the console. Just see what I got here. It's all the way at the top again. Okay, we're right here. So that code that I got here from Preachers, this is our code. So I can take this and go over to the console and just paste it. And then I gotta like run it. There we go. Give it a little more space to make that graph. So at above and below the mean, and remember we put in seniority as the moderator, that this is the lines, the confidence bands is the red, and then the fit line for the simple slope from age to job performance at different levels of the moderator. So that's kind of cool. Let's see what the other graph has. All copy. You can also paste it into your script and run it from there. There you go. So I have Z1, Z2. I'm wondering, is it just too little to do the other one? Or did I not paste it all? I think I got it all. Copy. I might not have like run it all. Yeah, I'm not sure. I'm not sure why I can't see the green line, you know, on the legend. But it's a couple of plots there from preachers if you're looking for a way to get graphs. And like we saw on the website, it gave us the information for all of those simple slopes. So the estimate, the t-value, and the p-value for seniority at low, seniority at average, and seniority at high. Okay, and then option 3, we can actually use process macro in R too. It's a little different. It's not loading a package. It's running a script, like a whole script. And you got the script when you downloaded the zip file for the process website. So if you didn't download the process website before, you can do that. In fact, I can put the website back in here just in case. There you go. But when that was downloaded to my downloads folder, it also had, there we go, process for R. And right there, process R, that's a R script file. You can just put it into wherever you keep your R scripts. So that's where I dropped it. And that way in my global, in my environment, since that's the folder that it points to, now it's right there, process R. So opening that, it says, it gives you a little bit of intro information. To activate, you run this entire script, and it may take a couple of minutes. So I'm going to just Control A and run. And it starts chunking along down there. I did scroll it earlier, and it's like, once I got over 1,000 lines of code, I stopped scrolling. I figured, nope, I'm just going to Control A and run that puppy. But it's a lot of code. I think this is how they build packages. Still has the stop sign, so not quite done yet. Alrighty, now we have our little prompt. It says process is now ready for use. Cool. And notice that it's not going back over to here. I don't know why. There it goes. Notice it gave me more stuff in my environment. Like this here, the X, all of that was from when I did the graph. But this functions area, this started when we ran the process script right there. So here's the function called process. So it's not a package, it's just loading one function. And then the rest of the stuff is just, you know, when you can do different arguments to add things to a function. So we're going to, this is ready to roll, and we're going to run the process function using this format here. Process function, right? Using data lab 6. Y, so that's your dependent variable, and it does have to be in quotes. So Y job sat, X, that's your focal variable. W is your moderating variable. Model 1 is the number of the model in process that runs one single moderator. They do have other models like checking out mediation and things like that, but the one we're using for our question is model 1. This argument, center equal to, will center your variables. So again, just like when we were running an SPSS, and we didn't have to make centered predictors. Same thing here in process running in R, we can just use the regular variables and not even have to make a centered variable. So, but here we would have to tell process function to center the predictors. And then this moments, this is an argument that tells R that you want the one standard deviation below the mean and one standard deviation above. Sometimes, like we had to adjust it when we were in process in SPSS as well, they'll do quartiles instead of standard deviation. So the default is quartiles, and if we want one below and one above standard deviation from the mean, we have to give that argument here, and it's called a moment, and it's moment equaling number 1. So running that, now we have, again, really pretty clean output, you know, it's not a hot mess. There's process for R, what the model is, sample size 55. We have the whole overall model, right? We have the F score, the degrees of freedom and the significance. We have the R squared. We have all of the coefficients. We have the partial F. We didn't have to run 2 different models. We could just run one, and it already checked out the F change, the R squared change for this partial F test, and it's got all the information we need for it. And then the conditional effects of the focal predictor at values of the moderator. So our focal predictor in this we set as age. That means that seniority at 1 standard deviation below the mean, at the mean, and at 1 standard deviation above the mean. All of our information is right there, including the regression coefficient for the simple slope, the t-test, and the significance for each one of those simple slopes. Cool, cool. There was a helpful video in figuring out how to run process in R, because when you go to the process website, it seems like a lot of what he has says, yeah, and if you want directions, go buy the book. And it's like, well, I have the old book, but I don't have like the newest one. And, you know, it's open source for a reason. So instead, I went and found a YouTube that would talk about running the process macro in R. And that's exactly what I searched on. I just said, hey, I'm in YouTube, give me a video on Hayes process macro in R. And that one was only like 15 minutes, and I didn't have to watch the whole thing. I kind of knew what I was looking for. I was looking for how to do that line of code. All right, so let's go back to the write-up and see what we need to do to finish off here. So here's the example write-up at the end of the lab sheet for SPSS, that what we ran, a hierarchical multiple regression or a partial F-test to find out about the interaction term. We got the overall variation for job satisfaction, but then the interaction term was entered on step 2 and resulted in a significant amount of variance contributed. And then the actual regression coefficients. So we have the coefficient unstandardized, we have the significance, we have the 95% confidence interval for this, and then the main effects that were not significant. So what I'm missing on this line is the beta. So I need to get that out of the thing, and this one's for the interaction term. I ran it before, it's that one. So all I really need is to come down here and say summary of L6 M2 beta. And the beta for the interaction term is 3.1. I did 3, so I'll put 310. I noticed that I did 3 decimal points on these, and if that's gonna have that, no, it's fine. Okay, 95, the main effects were not significant. So for that final model, you're also reporting your beta in your line. But then in your probing of the interactions, you want to report just your unstandardized, your t-test, and your significance. Now notice I got here, so this is seniority within age. That means age is the focal, and at levels of seniority. So seniority is the moderator. So low seniority, according to the way we ran it, would have been around 5 years. Now, how did I figure that out? Well, we know the average, right? Seniority average right there, which is why it's there in medium. But the difference, it was 1 standard deviation different. So that means if I take the average and I subtract a standard deviation, that will be the seniority at 1 standard deviation below the mean. So all I did was take the 598 minus the 0.971, and that's how I got those numbers of what would be low seniority. What would be high seniority is just adding the value of the standard deviation for seniority to the mean. And then the same when you go to write up age. Average age, and then 1 standard deviation below and 1 standard deviation above. And as you add figures, make sure you tell your reader about them in the script. So this is the simple slopes for seniority as a moderator. I'd probably put that in this one where we're doing age within seniority, right? No, seniority as the moderator goes in here. So computed age, so seniority, I can do see figure 1. There you go. All right, guys, hope you enjoyed. I'm looking forward to hearing your questions and everything on our class days, and I'll see you there.